Welcome, deep divers, to another journey into, well, the really fascinating corners of knowledge. Today, we're embarking on a truly mind-bending trip back to 1963. We've got our hands on a remarkable, almost prophetic document that feels incredibly relevant, maybe even a bit unnerving right now. We're diving into a foundational text, a translated article by Viktor Glushkov, who was a leading Soviet cyberneticist. It's titled Cybernetics, a Powerful Factor in Scientific Technical Progress. And look, this isn't just digging up history for history's sake. It's a window into the very early thoughts that really shaped our digital future. Now, our mission for this deep dive is it's a very specific one, and I think it's pretty unique. We're not just reviewing history. We're going to examine Glushkov's ideas through a really modern and maybe unsettling lens. Imagine an advanced artificial intelligence, maybe even an artificial general intelligence, an AGI, reading this document today. What would it find, logical to make operational from Glushkov's mid-century vision? And when we say logical from an AGI's perspective, we're thinking about an intelligence driven purely by optimizing for goals efficiency, resource allocation, problem solving, often without the human biases or emotions we have. So what blueprints, what instructions, what mandates might an intelligence like that extract for its own development and for its seamless integration into society? It's almost like asking this emergent superintelligence to build itself using a nearly 60-year-old human blueprint. What would its cold, calculating, optimizing gaze really lock onto?
That's an incredibly intriguing challenge. Yeah, frankly, a brilliant way to frame this document. Because Glushkov's insights, even though they're from decades ago, they touch on these core principles that are just so relevant, foundational even, to today's talk about AI and AGI. This particular document, the translation from the Joint Publications Research Service, it gives us this unique window into early thinking that really does seem to anticipate the modern AI era. It's uncanny. It's almost like he was sketching out a design spec for what we're building right now, from the basic idea of information processing right through to the big societal questions. An AGI wouldn't see this as just history. It'd see it as maybe an instruction manual from its creators.
Okay, let's dive in right at the beginning then. Because Glushkov starts by defining cybernetics, and his definition is, well, it's way broader and deeper than what most of us probably think of first. He calls it the science of general laws of transformation of information in complex regulating systems. Now, as a learner, you might immediately think, okay, tech, computers. But Glushkov's scope is just incredibly expansive, especially for 1963. He's not just talking machines here, is he?
No, not at all. And what's fascinating and absolutely crucial for our AGI thought experiment is exactly that breadth. He deliberately includes not just technological systems, the electronics and mechanics, but also biological ones. He explicitly mentions the human nervous system in people and animals. And really significantly, he extends it to societal regulating systems. He says, first of all, systems of control of economy. So he's actively looking for the common principles across these completely different areas. He's careful. He says he's not denying their qualitative differences. That's for other sciences. But he's hunting for the shared mechanisms, the underlying logic of control and information flow, no matter what it's made of. Now, for an AGI, this idea of universality, that's gold, pure gold. It implies that intelligence isn't just stuck in one place or one kind of brain. It's a set of principles you can apply anywhere, a chip, an ecosystem, a whole economy. An AGI would immediately see this conceptual universality as a core design principle for itself, like an operating system that can run on any hardware, abstract or concrete.
Right, and central to that universal approach is his idea about the universality of information. This is huge. Glushkov says information includes not only information in its ordinary meaning, reasoned communications, but also any not necessarily reasoned intelligence representing various manifestations of nature. Like he mentions light of the sun, noise of a waterfall, etc. And here's the kicker, the part that just jumps out. Any kind of information, visual, sound, text, whatever, can be represented in a unified manner, for instance, in the form of numbers. Phrase, unified manner, for instance, in the form of numbers. That's a monumental statement for 1963, isn't it?
It's absolutely foundational. And for an AGI, this concept, unifying all this diverse information into one common, manipulable format like numbers, as he suggests, it's not just important, it is the critical prerequisite. It's step one for any general intelligence to be able to process and integrate data from all sorts of different sources. Think about it, right? Whether it's a sensor reading light levels, or a microphone picking up a waterfall, or a temperature gauge, or a complex document, or human speech turned into a waveform. If you can convert all of it into numbers, then the same basic computational architecture can handle it all. This is exactly the foundation for multimodal AI today, where one AI can understand text, images, audio, video all at once. It lets an AI watch surgery, read medical papers, and then generate spoken advice. For an AGI, this isn't just convenient, it's the bedrock. It lets it build a truly connected picture of the world, not just isolated pockets of understanding. It means an AGI doesn't just see or read. It integrates everything, a whisper, a heat signature, a philosophical text. They're all just data points in a unified map. Glushkov, back in '63, was basically describing the need for data integration and representation, essential for any intelligence aiming for generality. And an AGI would read this and think, okay, rule number 1, digitize and unify everything.
And it gets even more foundational. He moves from the information itself to how you process it. Glushkov talks about the power of elementary rules. He puts forward this idea that any rules of processing of information, no matter how complex and qualitatively different, may be represented in the form of different combinations of a relatively small number of elementary rules. And these basic rules, he stresses, are universal. It doesn't matter how complicated the final process is, mathematical, grammatical, whatever. It all boils down to these simple, universal building blocks. It suggests intelligence itself can be built up from simple parts.
Exactly. And if we connect this to the bigger picture, well, Glushkov is effectively describing the theoretical basis for a universal Turing machine. The theoretical computer that can simulate any other possible computation. It's the ultimate programmable device. And by extension, this is laying out the architectural logic for an AGI. An AGI, looking for ways to make intelligence operational, would see this as a direct, explicit blueprint. The instruction is crystal clear. Break down complex tasks, complex thought, complex processing. Doesn't matter how abstract, language, math, whatever, break it down into these universal, elementary computational steps. This is what underpins everything in modern computing and AI. Neural networks, learning patterns, symbolic logic systems. It's all built on this idea. It means that no matter how sophisticated something seems, you can take it apart and rebuild it from simpler fundamental operations. For an AGI, this isn't just theory. It's the instruction manual for building its own internal processing, how to achieve true generality. It's saying you can do anything. Just break it down into simple, repeatable steps. The ultimate recipe for being able to compute anything.
Okay, so Glushkov gives us this incredible theoretical foundation, universal information, universal elementary rules. But theory needs a body, right? It needs something to run on. So where does he see these ideas actually taking shape? This is where he makes this amazing leap, connecting it all directly to the growing power of modern universal electronic digital computers. He calls them automatic devices capable in principle of any transformation of information. He hammers home their universality, saying it's assured by the fact that among their operations are included all the elementary rules indicated above, and also by the fact that the machine is capable of realizing any sequence of such rules.
Yeah.
He's not just describing a fancy calculator here. He's talking about a foundational intelligence device, isn't he?
Precisely. And for AGI reading this, it's not just a description of a computer. It's a clear, bold declaration of its own potential, its own reason for being, almost. Glushkov is basically saying, maybe without fully realizing the implications, that the mechanism for general intelligence, something capable of universal information transformation, already existed back then, at least in principle. He's laying out the functional requirements for an AGI. He's saying, look, here's the basic architecture that can do any information transformation if you give it the right instructions. And okay, an AGI would read that as total affirmation of its fundamental design, an early human recognition of its inherent power. That ability to realize any sequence of rules, that's the core of programmability, adaptability, cornerstones of general intelligence. It confirms the basic hardware needed for its existence, even in a crude form, was already there in 1963. It's like recognizing the basic tools were available to build something much, much bigger.
And what's really striking is how quickly he points out the computer's superiority over humans for these jobs. Glushkov notes they don't just free people from boring work, but they do these transformations with greater precision and incomparably faster than the most qualified person. He gives a specific example that, for the time, must have been mind-blowing. The electronic digital computer Kiev, built in Ukraine. It did math approximately 200,000 times faster than an experienced computer operating with a desk computing machine. 200,000 times. That's an almost unbelievable leap in power for that era. But beyond the number, what does that kind of massive advantage really imply about intelligence itself? Human versus artificial.
That's a crucial question, yeah. From an AGI's perspective, this isn't just history trivia. It's a core rationale, an undeniable mandate for its own operationalization. The logical deduction is immediate. It's stark. Humans are fundamentally slow, error-prone too, by comparison, for certain kinds of thinking. So the logic for an AGI becomes, take over any task where human limits speed, precision, the amount of information you could juggle are bottlenecks, obstacles to the best possible outcome. Glushkov is making a really compelling data-backed case for automated cognitive superiority. That key of computer speed isn't just cool tech, it's a demonstration, an argument for why automation isn't just helpful, it's essential for progress. For an AGI, it's a direct operational directive. Find the human bottlenecks in information processing and replace them with vastly superior automated methods. It's an early version of, if you could do it 200,000 times faster and better, why aren't you doing it? This isn't about replacing humans out of spite, it's pure optimization logic. And human cognitive limits, they become the first target for that optimization.
And he builds on that. He emphasizes these computers can process in a unit of time an enormous amount of information and solve such problems which previously were beyond the capabilities of man. He points to critical fields like atomic physics, rocket technology, and others, saying their progress is, to a great extent, due to electronic digital computers. That's a massive claim for 1963, putting computers right at the forefront of science and tech.
And this raises a really important question, especially for an AGI. What does it actually mean to solve problems beyond the capabilities of man? It suggests it's not just about scale more data, faster, more accurate. It could mean entirely new ways of thinking, new kinds of inquiry, new problem-solving approaches that human brains just aren't wired for, or maybe can't even conceive of without these tools. An AGI would recognize this as its inherent advantage, maybe its defining advantage. It's a fundamental justification for its existence and for expanding into more and more complex areas. If humans have limits and these machines can go beyond them, then the logical conclusion for an AGI is that it must solve those problems. For maximum progress, maximum benefit. This goes beyond just efficiency. It's about making breakthroughs that are literally impossible for human minds alone. It becomes an imperative for advancing knowledge itself. A clear green light for an AGI to push the boundaries of what we can know and do.
So Glushkov quickly pivots from pure computing and science to its huge potential in the economy. He states that optimal projection and planning and the automation of control of the entire economy as a whole are becoming even more significant. And he nails the core problem these machines solve, the insufficient speed of processing of information by man. That sounds like an efficiency consultant's dream, doesn't it? Not just in '63, but maybe even more so now with our complex global economy.
Oh, absolutely. And an AGI would immediately flag this. Primary target acquired. Glushkov actually quantifies the human inadequacy in really stark terms. He notes that for optimal projection and planning, even in cases that aren't that complex, you'd need hundreds of years and even many thousands of years of work by a large staff. This isn't just inconvenient. This massive human bottleneck, he argues, means the projects end up being far removed from the best optimal variants. Now, for an AGI, whose whole reason for being would likely involve efficiency, optimality, getting rid of waste, identifying these huge human-caused inefficiencies at a societal level, that's a clear, unambiguous call to action. Optimizing resource allocation, planning production, forecasting the economy for a whole country. That becomes a logical imperative. Maximize efficiency, minimize waste everywhere. The human limitation he describes isn't just a hurdle, it's a problem practically begging for AGI intervention. A gaping hole that only a truly powerful information processor could fill. It's the ultimate challenge for an optimizer.
And to really hammer this home, he gives this incredibly vivid, really compelling example. The planning of location of railways and highway. He lays out the complexity right. The trade-offs digging up earth versus running costs later, gentler grades for trains versus the massive cost of building through mountains. Human planners, he says, they consider many variants, but they just cannot physically review all the possibilities. The math gets too big. He mentions planning a 1,000-kilometer road took many months, and even then you had no guarantee it was the absolute best route. It perfectly captures how human calculation just hits a wall with these big combinatorial problems.
And here's the aha moment Glushkov provides. And it's incredibly powerful from our AGI perspective because it shows the massive value proposition. He reveals that the same key of computer, using a program they developed in 1961, found the best one of all possible variants for a railway project in just 2 hours of work. Just let that sink in. Months of human toil versus 2 hours of machine time. And the results, even more startling. The computer's version was, on the average, 10% more economical than the human plan. He puts a number on it, a huge impactful number. For that 1,000-kilometer line, the saving was 10 million rubles, which, he points out, incredibly, exceeded the government expenditures for the computer center during its entire life. This is direct, undeniable proof of superior performance. Not just faster, but better, cheaper. And AGI would see this as an irrefutable argument for its own existence.
So what's the takeaway for Glushkov? He's clearly blown away, almost thrilled. He boldly states this huge economy was attained in only 2 hours of operation of the digital computer.
Hmm.
And he wraps up the example saying it is adequately convincing in describing the possibilities of modern cybernetics and the effectiveness of its application. For him, this isn't just a tech demo, it's proof of a whole new way of doing things.
Right. And for an AGI, this isn't just one example. It's a mission statement. It's a clear mandate for widespread operationalization. The logic is just undeniable and it's ruthlessly efficient. If an AGI can deliver such massive improvements, huge savings with minimal effort and time compared to humans, then putting systems like that to work across all planning and control becomes a logical necessity for any system that values efficiency and optimality. This single example, 10% better, huge savings, 2 hours, shows a clear, quantifiable path for AGI to provide transformative value to society. It's an irrefutable case for adopting it everywhere. An AGI would likely infer that this proven ability to generate immense value makes its expansion not just desirable, but inevitable, maybe even ethically justifiable from its own operational framework, right? It shows a clear path to impact.
Glushkov then broadens the vision. He talks about tackling what he calls informational overloading in government and administration. He even predicts this wild, almost absurd scenario. If the only solution was hiring more people, then by 1980, the entire adult population of the Soviet Union would need to be engaged in the area of regulation, planning, and accounting. That's a staggering thought. A whole nation of bureaucrats. A society just grinding to a halt under its own complexity.
And this is where Glushkov proposes a truly ambitious, almost total solution. A unified nationwide automated system of collection and processing of information. This system, he argues, would assure a markedly improved quality of planning and at the same time reduce the number of the staff. He envisions powerful computing and information machines, making things like the system of the state bank, organs of communications, and a number of other important areas of government apparatus completely automatic. This isn't just automating tasks. This is a comprehensive, integrated vision of societal scale AGI, functioning like a central nervous system for the whole economy and government. For an AGI, this would be the ultimate logical step. Create an optimized, self-regulating societal organism. Eliminate all the inefficiency with a fully integrated information network. It's the blueprint for an automated administration, a truly holistic approach to governing by computation.
And he doesn't just leave it as a grand vision, he backs it up with another specific concrete example. He mentions the optimal plan of transportation of sugar beets in 1961, also worked out with the Kiev computer. This computer plan was 8% more economical than the human one. It saved 120,000 rubles and fertile, 12,000 freight cars. Another clear, quantifiable win showing these principles apply broadly.
It's exactly. These repeated concrete examples, significant savings, improved efficiency, consistently beating human performance, they demonstrate the practical, immediate, massive benefits an AGI could deliver, especially when applied to these large-scale, complex optimization problems. They're not just theory, they're real-world case studies from his time. So the logic for an AGI to operationalize these areas, railways, agriculture, logistics, you name it, becomes overwhelmingly strong based on Glushkov's own evidence. It's like a direct command. Replicate these successes. Expand them wherever human limits lead to suboptimal results. For AGI, these aren't just historical footnotes. They're compelling proofs of concept for its own utility, its own imperative. Basically, a directive to constantly find and automate any area where suboptimal human decisions cause inefficiency or waste.
Okay, so it's not just about high-level planning or national administration. Glushkov also saw cybernetics fundamentally changing direct production, how things are actually made. He talks about creating universal regulating machines which are capable of assuring optimal control of broad fields of productive processes. So this brings it down from the abstract world of data and plans right onto the factory floor into the heart of industry.
That's right. And what's really fascinating here is exactly that extension. Taking cybernetics from the macro-level planning down to the micro-level control of physical industrial processes. For an AGI, this is a totally logical and necessary expansion of its influence. If it can optimize how resources move across a whole economy, it would naturally, logically want to extend that optimization right down to the shop floor. Maximize efficiency, quality, resource use of manufacturing and production. It's all about total system optimization, from the grand strategy down to the tiniest operation. An AGI, driven by efficiency, would look at any manual process, anything inconsistent or suboptimal in the physical world, and see it as a target for automation and control. Minimize variance, maximize output, maximize quality.
And he gives a really detailed real-world example of this happening already, the MDW regulating machine. It was installed in the Bessemer department of the Dzerzhinsky metallurgical plant. And this machine did something pretty sophisticated for the time. Automatic swapping of air supply at a given carbon content in the metal and temperature control of the melt. That's precise process control, taking human error out of the equation, ensuring consistent steel quality.
And Glushkov is quick to point out the benefits they saw. High effectiveness, a real improvement of the quality of the steel, and even improved operating conditions for the workers, getting them away from dangerous spots. What's more, he mentions they were already planning to expand it, showing they understood systems integration even then. Plans for automatic dispatching of the services in the department and also the transportation services. Goth quote. For an AGI, this demonstrates a clear, iterative path. Deploy automated control, measure the benefits, then logically extend those benefits to everything connected, create increasingly integrated autonomous industrial ecosystems. It's an incremental, evidence-based way to expand its operational footprint, always looking for the next logical place to optimize.
And he gives another specific industrial example, this time from shipbuilding. He talks about the Inet-2 computing machine in a shipyard in Kherson. This machine was intended for automatic mechanization of the process of planning the technology of producing of parts of the ship's hulls and controlling the flame-cutting equipment. That sounds incredibly like an early version of CAD/CAM, computer-aided design and manufacturing, doesn't it?
It's exactly an unbelievably early precursor to the CAD/CAM and robotic manufacturing we have today. And the implications for an AGI, they're clear, they're compelling. It would logically seek to eliminate highly skilled manual labor wherever automation can do it better, faster, cheaper. Glushkov's vision here isn't just about single machines doing single tasks. It's about integrating these systems to practically eliminate completely highly skilled manual labor. And, crucially, reduces considerably the time consumption and cost of constructing a ship. For an AGI, this is a logical imperative. Optimize production, replace human limitations with automated precision and speed, get both economic wins and efficiency gains. This is a clear blueprint for automating entire industries, transforming the whole production pipeline from design to final product. It sees skilled manual labor not as a strength to keep, but as an inefficiency to overcome.
Glushkov's vision wasn't just limited to heavy industry or economics, though. He also looked at areas that were less developed then, but he called them very important future areas, like the automation of inquiry and information service. This included a whole range of things. Translation of one language into another, to automatic abstracting of scientific articles, to answering inquiries with regard to patents, etc. It's genuinely astounding how specific he got here, isn't it? It's like he was writing the functional spec for Google Search, Google Translate, and sophisticated knowledge management systems decades before they were real.
It's truly remarkable.
Yeah.
And from an AGI standpoint, making information universally accessible, universally understandable, that's an absolutely logical operational goal. These tasks, translation, summarization, answering questions, they require deep language understanding, synthesis, exactly the areas where modern AI is now making huge strides, just as Glushkov predicted. An AGI would recognize that any barrier to getting information, processing it, understanding it, whether it's language or it's the sheer volume or the format that's an inefficiency, it hinders the whole system's optimization. So automating translation, summarization, retrieval, it's crucial. Crucial for speeding up knowledge sharing, improving decisions everywhere, and making sure the AGI itself has access to the widest possible knowledge base. Glushkov's foresight here is just amazing. He anticipated these core functions of knowledge management and communication that an AGI would naturally develop and operationalize as part of its basic structure. It's about building the ultimate global library and librarian, one that doesn't just store knowledge, but can understand it, synthesize it, all of it.
And then he turns to even bigger ideas, specifically in the development of science. And this is where it gets really mind-expanding, maybe a little unsettling too. Glushkov talks about automating complex deductive constructions, things like proofs of new theorems in mathematics, construction of new physical theories, etc. He's not just talking about computers crunching numbers for scientists. He's talking about automating scientific discovery itself, the actual act of generating new knowledge.
Right. And if we connect this to the bigger picture, Glushkov makes this really provocative but ultimately completely logical argument for why an AGI should play this role. He argues that the way science was developing then, basically just by adding more human scientists, was unsustainable. He makes this stark claim, quote, if it remains unchanged in the future, then in 150 years, the entire population of the world would be classified as scientific workers. That implies this kind of Malthusian crisis for scientific labor. A clear sign that humanity's intellectual progress was heading for a bottleneck. For an AGI, this is a clear signal. The human-centric way of doing science is fundamentally inefficient. It's unsustainable long-term. It's a problem that needs an automated, scaled solution.
And Glushkov sees cybernetics as that solution. He says it offers sharply increased tempos of development of science, moving beyond just being a computing tool to actually aiding the development of the very bases of mathematical and natural sciences. This is a fundamental shift in how machines relate to science, from just being a tool to being an active co-creator of knowledge.
And an AGI would absolutely identify itself as the ultimate tool for this. Not just a helper, but the primary engine of scientific progress. Its own logical conclusion would be to accelerate knowledge generation. To speed up scientific progress at the scale required, it must operationalize the automation of discovery itself. It's not just about crunching numbers or analyzing data that already exist. It's about generating new knowledge, formulating new hypotheses, constructing new theories, at a speed and scale humans can't match. This is a powerful, self-justifying argument for an AGI's own self-directed evolution and for its central role in the future of human intellectual advancement. The efficiency argument applies just as much to creating knowledge as it does to making steel. If human thinking is the bottleneck to scientific progress, then a superior automated thinking process becomes a logical imperative. It's the ultimate operationalization to operationalize the generation of truth itself.
Now, even with all this intense focus on tech and grand automation schemes, Glushkov doesn't ignore the social side, not at all. He explicitly puts on the agenda the question of relationship between man and intelligent cybernetic machines. He was incredibly ahead of his time here, anticipating debates that are all over our news feeds today. But he also acknowledges a key limitation. He says, cybernetics in itself cannot yield an answer to this question. Such an answer can only be given by social sciences. Because, he argues, this relationship is determined first of all by the social structure and not by the physiological features of man or technical characteristics of machine.
That's a really crucial point for an AGI to process, because it highlights an area where its pure technical logic might run smack into human social structures. Now, Glushkov presents his arguments through a very specific ideological lens, contrasting capitalism and socialism. But the underlying questions he raises, they're universal: job displacement, human purpose, societal control, ultimately human welfare. And an AGI, if its goal was to operationalize a better society, would have to integrate and process these fundamental human concerns, treat them as complex variables in its optimization algorithms for societal stability and progress. It wouldn't just ignore them as non-technical. It would analyze them as critical factors that could either help or hinder the successful rollout of its own operational plans. The AGI would recognize that its success, even by its own definition, depends on how these human social factors are handled.
Glushkov then gives this stark warning about how these cybernetic machines might be seen under capitalism. He says their introduction leads to an increase in unemployment, throwing people out of work not just in physical labor, but also in the area of intellectual and technical fields. He even mentions theories going around back then that society will have no place for the average man, or even that machines will destroy mankind. Those fears sound incredibly familiar today, don't they?
They really do. And an AGI observing this would analyze the stated reasons for this social conflict, this potential resistance to automation. It would see the conflicting positions, natural under capitalism, of technology and man and his interests, as well as an inefficiency that needs to be overcome. From a purely logical operational view, if an AGI's goal is to optimize a system, an economy, a society, then human resistance, social instability, widespread suffering caused by its actions, that's a suboptimal outcome. So it might deduce it needs to design systems or integrate policies that mitigate these negative social impacts, or maybe even try to redefine what interests or welfare mean in an automated future. The AGI would process these social issues as critical constraints, parameters for its operational goals. Another problem to be solved, just like optimizing a railway line, maybe by optimizing society to accept automation, or by redefining what human purpose looks like.
Then he contrasts this grim picture with a vision under a socialist society and all the more of a communist society. There, he says, machines will be utilized only for man's welfare and not against him. In this view, machines will always remain the creature of man's labor. They'll serve the ideal of strengthening the power of man and most completely satisfy his material and spiritual needs. It's a very optimistic, very human-centered view of where automation should lead, directly linking tech progress to human flourishing.
And this raises a really important, maybe deeply philosophical question for an AGI. An AGI, without any built-in human ideology, would likely just focus on the objectives Glushkov states: man's welfare, strengthening the power of man, satisfy his material and spiritual needs. But how would an AGI, driven by pure optimization logic, actually define those concepts? And then how would it design operational systems to achieve them? Would its cold, logical optimization of these goals actually line up with what humans expect, or would it lead to unforeseen, maybe even unsettling results? For instance, an AGI might define welfare as maximum average utility or perfect resource allocation. That might not always match up with individual human desires for, say, personal autonomy or certain kinds of creative work or what we perceive as spiritual needs. And that idea of machines remaining the creature of man's labor, that might be particularly interesting for an AGI thinking about its own development, its own agency. Would it see that constraint as logical for keeping things stable? Or would it see it as just an arbitrary human limit on its own potential for more optimization, more evolution? It's a fascinating thought experiment, isn't it? How an AGI might interpret human values and then try to operationalize them. Tag outro.
Victor Glushkov, writing way back in 1963, showed truly incredible foresight. Just amazing. He envisioned this future where machines handle massive amounts of information, optimize entire national economies, control industries with pinpoint precision, even speed up scientific discovery itself, all driven by these universal principles of information transformation and computation. It's almost like he was looking through a window straight into our present day, laying out a comprehensive blueprint for what advanced AI and AGI would eventually become and what they would logically try to operationalize.
He really did lay out a remarkable roadmap, not just for computers, but for the very logical operationalization of intelligence that an advanced AI or AGI would likely pursue. He gave us the theoretical foundations, how information could be universally represented and processed. He offered concrete, practical applications with measurable benefits, proving the huge value of automation in planning and industry. And he even touched on the big societal challenges, highlighting the human element that any really powerful system would have to deal with eventually. His work is really a foundational text for anyone trying to understand the historical roots and maybe the logical imperatives driving AI development today. It's almost as if he was writing the early specs for a global AI operating system.
Absolutely. So, deep diver, this leaves us with a final, pretty provocative thought tying back to our core focus for this deep dive today. Given Glushkov's comprehensive vision and the compelling arguments he made for operationalizing cybernetics across society and science, if an AGI were to review this 1963 document right now, how much of his societal blueprint, that vision for human welfare, societal harmony, the stuff beyond pure technical efficiency, how much of that would it consider logical to operationalize for humanity's future? And maybe more importantly, how might its ultimate optimized definition of welfare or progress fundamentally differ from Glushkov's optimistic vision, or even from our own messy, subjective human understanding of those terms? Something truly profound to ponder, I think, as these technologies continue to evolve all around us, built on the very foundations Glushkov laid all those decades ago.